Hello folks and welcome to this special live stream building your first app with SwiftUI and SwiftData. In this video, we're going to build a complete app from scratch, all focused on SwiftData, storing your data there safely. You'll need some knowledge of SwiftUI attached to this already. I'm not doing SwiftUI from absolute basics here, but I will try and cover all the SwiftData stuff from scratch, so you can learn along the way. If you're watching live, this stream thing on the right here is the chat window. Folks can ask questions and get involved and so forth. Directly below the video, by the way, is a link to Just Giving, because today is my birthday and I'm running this stream live to raise money for folks experiencing homelessness. And so, if you can, I would very much appreciate it if you could donate some money to the cause. It's, again, folks who are experiencing homelessness or escaping domestic abuse or recovering from leaving prison and so much more. They do wonderful, wonderful work, and your donation matters this winter. Now, the app we're building, folks, I've got it here running on my iPhone already. I think it shows off quite a lot of Swift data already. It's called Face Fact. It's about helping you remember the folks you have met at various events, meetups, whatever, at your workplace, school, who knows what. And you can see here, you can add people to the listing here. You can swipe to delete. You can sort them in different ways. You can filter them with searching. You can go into them and attach pictures. There are relationships. You can track where they were met and so forth. There's a lot of stuff in this tutorial, really cramming it in. I've tried to get as much of Swift data as I can into a single stream. Great. Thanks for the donation, folks. Honestly, every pound, every dollar, every euro, everything you can have helps at this time of year because it is quite viciously cold. Anyway, along the way, you're going to learn lots about Swift data, lots about SwiftUI. There's so much going on. If you haven't seen Swift data before, it is Apple's framework for storing data, querying data, persisting data generally in an effective, efficient way. It's lots of fun to work with, and as you'll see, you can get a lot done very quickly. You will need to have installed Xcode 15 or later. You can see I'm using Xcode 15.1 here. 15.2 is fine. You will also have to have iOS 17 obviously attached to it. I'm running 17.2 here in the simulator. A real device is obviously preferable, but simulator works very well too. And along the way, if you are coming on live, please ask questions. I'm here to answer questions and help you understand things better. So if you are here live, ask questions, get involved. It's a great way to learn too. Question already, how long do I think the stream will take? I've got no idea. I mean, let's call it 2 hours, but it depends on the questions and tangents and diversions along the way. There's lots to see. We'll see. Anyway, to get started, we're going to go ahead and make dogs already. I'm going to go ahead and make a new project in Xcode here. So choose Xcode, create a new project. Then choose iOS and app. Then press next. Like that. Hello, other dog. Boom, there you go. Now the app we're making is called Face Facts, because it's facts about faces, you see. I'm being a bit clever here. Thank you so much, Oscar Alvarez. It's very generous of you. And Simon as well, thank you so much. Anyway, it's called Face Facts. Facts about faces. It's a nice sort of punish kind of name here. For SwiftUI interface, that makes sense, but please don't change storage to SwiftData. Leave it as none. We'll bring the whole thing in from scratch ourselves, rather than having Xcode make a ton of code for us here. So press next, and then create that somewhere you can get to. I'm going to go ahead while that's working and reset my simulator to destroy the current copy of the app I have. So we start from a clean slate in my simulator. So I'll just do erase all content settings like that. Boom. My dogs, this one's called Aria, the very hungry one. The one down here out of reach is Luna, but she knows when there's treats going, she can get some. One more each and you go away. Okay, I got work to do. One for you, one for you. All right, out. Out, out, out. Skedaddle. Out. Dear me. Okay. Yeah, the dogs always know what's going on. Stephen, no, there's no plan to do widgets. We'll do CloudKit though. So, you win some, you lose some. So, I have reset this. Here's our basic Xcode app template for SwiftUI here. Again, no Swift data. It's just pure SwiftUI stuff, which is great. The first thing I'm going to do is bring Swift data into our project, and there are 3 fairly small steps to do this. First, you want to define the data you want to work with, like what you actually want to store. Second, make some storage for that data. And third, go ahead and read whatever you want, wherever you want it. And they're all, honestly, fairly small steps. Tyler, no, there'll be no enums involved in this application. So, first thing we're going to do is design our data. Like, what do we actually want to store? Now, for us, this will be simple. We'll add a little bit more later on, but we'll start simple. We'll store 3 pieces of information about a given user. We'll store their name, their email address, and then a free text details field. You just add any extra information you want about that user. So the first step here is to press Command N and make a new Swift file under iOS here. Then call this thing person.swift. This will define a single person in our application. What do we know about a single person? In our case, like I said, we're going to store those 3 things, the name, email address, and details. So I'll make inside here a new class called person that stores those 3 pieces of information. So we'll say here we want the name as a string, the email address as a string, and the details as a string. So 3 simple strings in one class. So each person has those 3 things there. Now, because it's a class, we've got to add an initializer for it. It's required for classes. And so we'll add one here. Just go into the class, type IN. It'll just fill it in for you. Enter, boom. Initializer done. Now this is a boring Swift class. Nothing special like this. There's no Swift data here at all. It's just a regular Swift class. What we want to do is tell SwiftData that this thing can be loaded and saved. And to do that, we're going to add an import for SwiftData at the top, and then add a macro here to say this is handled by SwiftData. We say @model class person. So both Glenn and Aaron are asking why use a struct rather than the class. So if you imagine a struct of data and you have it, say, in the home screen of a user, and you go to a detail screen and then go somewhere else and somewhere else and somewhere else, and somewhere in the app, you change that value. You edit the user's name or email address or details. How would you make sure that same value also changes everywhere else it's used in your app? Now, with classes, they're automatically shared. Change one, they all change. With structs, that wouldn't happen. So what they could do is say, well, you know, we want to use structs. We like structs very much in Swift. What if we had a special little pointer ID tag in our struct that refers to it uniquely? So when it changes, everywhere else that same ID looks at that ID and says, okay, I'll change as well, and they refresh themselves. They could have done that. But what they've basically made is classes. They basically made a pointer to a class, which is how classes work in the first place. It wouldn't be any more effective. And so in SwiftData, nearly all the time, you want to use classes and not structs, particularly when dealing with relations, as we'll get onto later on. They're very messy with structs, I've found. I wouldn't recommend them. Simple value structs work okay, but they make it rather hard to query. So yes, you do want classes here. So macros, like this one here, rewrite our code at compile time, adding extra functionality. In this case, it rewrites this person class to add all the functionality to back this thing by SwiftData. These are not just simple strings anymore. They instead read and write string values from SwiftData's long-term storage. Now, if you ever want to see what a macro does, just right-click on it and choose Expand Macro. And you'll see that's what it actually rewrites our class into. Lots of things happening here. And you can see that name and email address and details are all now marked as persistent properties. The underscore means it's kind of private, don't use me directly. That's also a macro which you can expand further and see there's more code inside that. There are now getters and setters to read and write the values from SwiftData. So that one @model macro does lots of work for us. You can go ahead and click Hide Macro Expansion to get rid of all the junk. So it looks like we're handling a simple class, but not really. There's lots of work happening here behind the scenes. That's the first step. We've now defined our data. We want to store a person. Each person has a name, email address, and detailed string attached to them. The second step is to tell SwiftData we want to use this person class in our application. And this is done by making a model container for the class, which is SwiftData's way of loading and saving values from the iPhone's SSD. So over in our FaceFacts app struct here, we're going to add one modifier to the window group called model container for. We'll write here .model container for person.self. That thing comes from SwiftData. So add another import here for SwiftData. And that's step 2 done. Now what this thing does is when our app runs for the very, very first time, SwiftData will say, okay, you want to use people, that's fine, it's person class here. I'm going to go ahead and make the underlying database storage to hold a person object will make over time. But then all subsequent runs, second, third, fourth, fifth, 1,000th, whatever, it loads that existing database for us to use. So it creates it once and loads it all subsequent times. Now, behind the scenes, SwiftData is really just core data, which itself just backs onto SQLite, a common database format, system, sorry, not really format. Of course, SwiftData then adds on top of that things like iCloud, synchronization, and much, much more. It's very powerful, but it is ultimately a database behind the scenes being made for us. So that's step 1 and step 2 now complete. The third step is to go ahead and read some data wherever we want it. Now for us, that'll be in content view, at least for now. And so in content view up here, I'm going to go ahead and make a query. I'll say, hey, SwiftData, give me all the person objects you're managing. No good, Nix, make sure you have that import SwiftData thing added as well. Ryan, at main is not a macro. At main is special and separate. So here in our main content view here, I'm going to say, just go ahead and query for me all the person objects we have here. And so we can say, again, import SwiftData, and then at query even, var people is an array of person. That's it. That tells SwiftData, please go ahead and load all the person objects you're managing right now, and that's literally all it takes. Even better, this at query, which is another macro by the way, will automatically keep that array up to date. So if value changes, we add a value, delete a person, whenever, that will refresh the SwiftUI view automatically for us, keeping it up to date at all times. So it'll load all the people and stay up to date over time. It's absolutely brilliant. We'll look at things like sorting, filtering, and more later on. But for now, we're basically done with our SwiftData setup code. We can add just enough SwiftUI to kind of show things on the screen. So I'll say this default body code can just go away. I'll ask for a navigation stack with a list inside. And in the list will be a for each. Over that people array, give me one person coming in. Then we'll make a navigation link for that person with the value of the person itself. Let's shrink the sidebar down slightly. There we go. Boom. And then do a text of the person's name inside. We'll add a little title like nav title. It's called FaceFacts. We'll add a little navigation destination. We're given a person. Go ahead and give me that person coming in and just show it in the text view for now. We'll do more later on, but it's enough for now. Like that. So that is our basic SwiftUI code just to work with our SwiftData objects. You can, if you want to, run the app. I wouldn't. There's no point. It'd be rather dull because, yes, all our SwiftData code's in place and our UI will work correctly, but there's no actual people being stored yet. We haven't made any data. Let's fix that next. Speaking of which, to remind you I have a chance somewhere, just giving, I have a link I should give you really, or someone's going to put it into the thing perhaps. This one? That's the one. Yeah. That's my Just Giving link. I'll put it into the YouTube chat here. If you want to donate to this cause, you can do. I would much appreciate it. This is all going towards Julian House, which help folks who are experiencing homelessness, escaping domestic abuse, and so much more. And already almost doubled our target. Thank you so much. Okay. Other folks post a link in that future, in the future perhaps. Okay, so we've got our setup data all in place. It's now time to actually handle editing and editing users somehow. And of course, we want to just say, yes, go ahead and add custom data, but then let them change their mind, edit it and delete it, whatever, freely over time. If you look at the way Apple's Notes app solve adding and editing, it's brilliantly simple. When you press the plus sign to add a new note, it creates an empty note and then navigates to it straight away. What this means is adding and editing are really the same thing. They're not two different views entirely. It eliminates lots of extra work. We can take exactly the same approach here. We can make a new method that creates a new blank person object, then immediately navigate that to editing. So just create and push to it straight away, so editing the new thing straight away. Completing this thing takes, I think, 4 steps in total. First, we'll make a new view that handles editing person data. Again, our person class is very simple right now. We'll add more later onto it. Second, we're going to change our current navigation stack so we can control its path programmatically. We want to push to the new person when they're ready. Third, we'll make a content view method here that makes the person and navigates to it. And fourth, we'll call that from a toolbar item. David asks, if person changes mind, presses back, we delete the note. Yeah, if you want to, sure. It's down to you. I mean, how much data do they have to provide till you're happy that it's empty? For example, if they provide just the details text, should you delete the user? Or if it's all empty, do you delete the user? I don't know. I'm not going to do it here, but Notes just says, okay, the note was empty, just delete the note entirely. It's down to you. Porter asks, does SwiftData automatically handle DB migrations? It does its best. You'll see one here later on. Tyler asks, if you want to present a person's name only, no list. So it's designed to load arrays queries. It doesn't handle single objects at this time. File feedback with Apple if you want to, asking for that. You could, of course, just read the first object from the array, which happens to contain one object. That would work too, but right now it loads arrays. Once we have those 4 tasks done, we can go ahead and add edit users freely, have an actual usable app. And so let's get started now. Let's press Command N, make another new file, choose SwiftUI view this time, and call this thing edit person view, like that. Now, this thing needs to know really only one piece of data, which is the person we're editing. So I'll press create in there and give it exactly one property. Our person is a person. That's what we're editing right now. Now that's immediately, as you can see, going to cause an error down in our views preview area because it wants to know what person to pass in for previewing purposes. Rather than create this error now, for now, just for now, select it all and press Command/ to comment it out, to comment the preview out entirely. We will fix this later on in one big lump, but I want to kind of get the main app finished first. Otherwise, doing a lot of previewing, jumping around. Let's try and stick to one task at a time, building the app right now. Thank you for the donations, folks. It all helps. So we have now a new view with a person property inside, and the preview is commented out. Our current person class has 3 properties: name, email address, and details. And we want to edit all 3 of them as text fields here. But there is one small speed bump. If we start filling in the body of this view, you'll see it pretty quickly. I'll make a form with one section inside. And inside there will be a text field prompting for the name and binding the text to $person.name. I'll give this thing a text content type of name and then add a nav title of edit person and a navigation bar title display mode of .inline. That's our starting form. And boom, there's a speed bump. Swift does not understand what $person means in this scope. When we have a local property declared using @state or similar, SwiftUI automatically makes for us 3 ways of accessing that property. For example, if we had an integer called age, and we read age directly, just AGE directly, we can get or set integer. There's no wrap around it, just int directly, okay? If we used $age, then we get a binding to the data, which is a 2-way connection to the data that we can attach to SwiftUI views. For example, for integers, we might say, there's a stepper controlling someone's age, and you can press up and down, and it'll change the property as the stepper changes. Change stepper, property updates. Change property, stepper updates. It's a 2-way connection. We can also write _age, a 3rd way, which lets us access the underlying state property wrapper directly. It's a struct behind the scenes, which is helpful when we want to initialize it in a very custom way. So 3 ways of getting our data. That's with @state. But here, we aren't using @state. This is just a simple, basic instance of our person class. It has no way of exposing bindings to us with text field or any other SwiftUI views. Now, fortunately, this is easy to fix because SwiftUI has a property wrapper that automatically makes for us bindings to an object. In fact, all it takes is adding that one property wrapper here, and the problem just goes away. We can write @bindable, like that. So our view still expects to be handed a person object to edit. But when it gets passed in, SwiftUI will automatically make bindings from that for us with the @bindable wrapper. So meaning we can now use $person.name to get bindings to the underlying string, just like we wanted in the first place. Some questions. Sirena says, I don't really like SwiftUI, feels like heaven. Oh, like UIKit, phew. I think focus on SwiftUI. Honestly, at this point, UIKit is kind of fading in its career. I've done a lot of code in UIKit, but SwiftUI is very, very much on the rise, and Apple are not beating around the bush on that front. PA5QIAA, should you make view models? If you want to, you'll find it very, very hard in SwiftData. It's an absolute nightmare in SwiftData MVVM, and so I wouldn't necessarily recommend it. Anyway, with that bindable wrapper in place, we can now go ahead and fill in the rest of our form. I can say down here, a text field for the email address with its text bound to $person.email address, person.email address. Come on, email address. I give up. That's why I come to live streams, folks. With a text content type of email address and a text input auto capitalization of never. Moxific, you want @bindable here. This is used with an observable object type. That's an observable macro object type to create bindings from it. @binding is used for local copies or local references, of external state. Different thing. Very similar naming though, which is not helpful, but you do want @bindable here. Ryan, no, @bindable does not replace that. Observed object is replaced by observable, the macro. Yes, how to fold. Make sure you have made your person class use the @model macro. If you have not done that, it will not work. Okay. So, we'll also add another section below for our notes. So section here, notes. Text field, we'll do details about this person with a text bound to $person.details. And I'll add this time axis.vertical, meaning that this text field will grow vertically as the user types more than one line. Great for long sort of form detailed text stuff. We'll add more later on, but it's enough for now. That's the first step done. A view to edit our person data. The second step is to upgrade our navigation stack so we can control its path programmatically. We can add things to there and therefore push to a new view when we're ready. This means making some local state in our content view to store the current path and then bind that path to the navigation stack. Now, navigation paths can contain all sorts of objects. For now, we just need one type of data, the trying person we're trying to edit in the first place. And so our path will simply be an array of people. Peter, this text content type modifier tells iOS to expect a name being typed in here, and so that we'll get auto completion options for the name or for the email address. It's a nice user helper, and it's actually, I find it very annoying when apps don't use this because you got to type in your full email address by hand, which is, grr. Anyway, back in our content view, we're going to make some state to store the path we're working with. So I'll say up here, at state, private var, path is an array of person, like that. Justin, wouldn't I use, so for this one, I honestly wouldn't recommend using sentences for someone's name. It's complicated. And I think when you try and make assumptions about names, it nearly always goes wrong. I'm thinking in particular, like Dutch names, like my friend Antoine van der Ley, van der Ley, the V and the D, is that caps or not? I don't know. It's best not assuming. Just stick with the name and let iOS sort it out. Anyway, this is our path we want to have in our navigation stack here. And now we can bind that to our navigation stack. We'll just say this thing has a path of $path. Now this is a two-way binding for the nav stack. What that means is as the user manually goes between views, it will change this array to match what they're viewing. But two-way, if we change the array, it will push or pop things from the navigation stack. The third step here in this little goal is to write a method in our content view that creates a person, then navigates to it immediately. This step is slightly more complex. And so we'll break this thing down to like 4 mini steps, okay? First, we're going to get access to where SwiftData stores information. Second, we want to make our data. Third, we want to tell SwiftData, hey, this matters, please store it. And fourth, we want to navigate to the editing screen. So 4 tiny little mini steps here. First of these requires introducing another important SwiftData concept called a model context. Now, you've already met model containers over here. We make one right in our FaceFact abstract, okay? This thing is responsible for loading and saving from the iPhone's permanent storage, actually making the database for us, loading it, preparing it, handling, syncing, whatever. It's all done through model container, okay? Model contexts are a bit like a data cache. If you imagine reading and writing SwiftData objects from disk again and again and again for every little request, you can see pretty quickly it'd be inefficient, okay? So what happens is SwiftData gives us a model context. It loads objects into RAM, into the context, works with them there, and then writes them out when we're finished. And so when we used @query over here in content view, SwiftData knows, okay, I'll load these people from SSD into our model context, into RAM, and it stores them there, keeps them alive there temporarily. We can then go ahead and make all the changes you want to, adding things, deleting things. You can modify things as much as you want to. And at some point in the future, they'll be written back out to disk. So it goes from RAM back to permanent storage once a save is triggered. Does model container work in multi-module projects? Goodness me. Well, you can have as many model containers as you want to, if you genuinely want to have that. They are the only thing in SwiftData that are safe in concurrency, to be passed around freely. Don't do it with context. Contexts are dangerous to be shared. Don't do that. But containers are safe to be passed around between different parts of your app, different actors, for example. And so you can do that. And so, yes, if you want to have containers in different ways, just be careful. I think sometimes folks think that I'll have this data in this container, this one in this container, this one over here. Da, da, da. But if they are somehow linked together, if this container loads some data from over here, it'll be pushed across the other container. So it can kind of pollute your data very easily. So be careful with that one. Anyway, the query. That thing says, get me all people from disk here and put it in RAM, basically. Put it in my context to read and write these things here as much as I want to. So this model context allows SwiftData to batch things together efficiently. But it also means when we make a new person object and we're adding a person on a database, we don't just say, please write to permanent storage now. Instead, we insert it into the model context and let SwiftData take over from there. It'll be saved automatically in the future. So this is where SwiftData does three very cool things on our behalf. First, when we used this model container for person.self thing, it silently made a model context for us called the main context. This one always runs on Swift's main actor, so it's safe to use from all our SwiftUI code. Second, it automatically placed that model context into SwiftUI's environment, so we can read it out and use it to insert our own objects in the future. And third, this query macro knows to look in the SwiftUI environment to find that context. That's why it's able to load all our data without any extra work. It talks to the environment, finds the context, finds the container, loads it all for us automatically. It's very, very nice. So our first mini step here is to get access to where SwiftData stores all its information, which means we're going to read that shared model context, that main context, out of SwiftUI's environment. So we'll say here, at environment / model context var model context. Glenn, does the OS manage the size of the model context? Yes, it does. Matthias wants me to do some exact coded project. That feels like some sort of college homework project, Matthias. Do it yourself. Anyway, I know that was a lot of explaining for like one line of code, okay? But it's hopefully understand what these model contexts do and why they're important. The second mini step is actually making our data, and we'll add a new property, a new method down here called addPerson. This will make the person object. So I'll say our person is a new person named nothing, email address, nothing, details, nothing. I'm giving them empty text for all three properties, which means when you display it for editing, user will see placeholder prompts for all those fields rather than just some sort of dummy text. Our third mini step is telling SwiftData, hey, please store this new person for us. Just making it is not enough. Just saying as a new person is not enough. You'll actually store it away somewhere. This means inserting it into our model context, which takes just one line of code. After this, I'm going to say model context.insert that person, like that. That is 3 out of 4 mini steps done. The final mini step, we've now made our person. We've added to SwiftData's context here. We're going to navigate to our editing screen. This means changing that path property we made earlier, this one here, to say, this is the person we are now editing. Please push onto the screen. And so here, after the insert call, I'm going to do path.append person. So please navigate there. Now, right now, our navigation destination is just saying, show the person's name as text. Clearly, that's not enough anymore. We want to navigate to our edit person view instead. So I'll replace that text with edit person view, person of whatever person they chose, like that. So that is in the bigger goal here. That's now 3 out of the 4 big steps done towards the larger goal. The last one is simply calling addPerson from a toolbar button when we're ready. And so after the nav destination, I'll say there is a toolbar with a button saying addPerson. System image can be plus, and the action will be addPerson, like that. And now go ahead and run the app. I think it actually should work fairly well. Let's find out. It's thinking at full speed. So you need to show some AI magic. So you may or may not know that ChatGPT has a current knowledge cutoff of April 2023. In its head, I don't think SwiftData even exists. So good luck with that. Anyway, face facts here. I'm going to press plus. I'll add a person here. My name is going to be, come on, hide the keyboard please. Dave Lister. Email address dave@reddwarf.com. And then go back. Boom. So we've pressed plus. It brings the editing screen straight away. I filled it in. I've gone back. See the person right there. I can go in and say, oh, not Dave. He prefers, I don't know, David. And then go back. That updates nicely as well. I can then say, okay, let's leave the app entirely. And then quit the app. Relaunch the app. He's still there with changes in place. Given how little SwiftData code written, I think it actually works pretty well. It's doing a heck of a lot of work for us here. Not only is it correctly reading and writing data for us, but also keeping all SwiftUI views in sync as it progresses. So that is adding data completed. It's a good reminder, folks. I am doing this live stream on my birthday because I'm raising money for folks experiencing homelessness. Go to the Just Giving link below the video if you want to donate. The name will appear on the screen as well with how much you donate. No pressure. All donations are most welcome here. It is winter. It's cold outside. Folks need our help. Okay, now we can add stuff. Let's do the next thing here because there are 4 basic tasks folks want to do when they have a database-driven tool like this one here. They want to create stuff. They want to read stuff. They want to update stuff. They want to delete stuff. Often just called CRUD. Create, read, update, delete. Right now, we have the first 3 of those. We've got CRA or something, right? To add the extra D to this, to get deleting working, we're going to add a method in this view here that can delete people from our model context based on whatever data SwiftUI passes in. So we're going to attach that to an onDelete modifier and it will work correctly. Beta's getting some warnings. Ignore them. That's SwiftUI just spouting junk. Roman asks, I actually use the SQLite 3 command line tool normally, Roman. It works very, very well. Andrea is confused at navigation links versus nav destination. Nav links passes data in. Please go to this, please. Navigation destination says, when you receive one of these values, here's how you handle it. So it's data being passed in, data being received and acted on. So it's separate. I mean, you can try. Good luck. It becomes, if I remember correctly, query is a macro which backs onto a query property wrapper. It's kind of confusing and a bit difficult, so I wouldn't recommend it. Serious Cat suggests maybe having a save button. That you could add that. Of course, you can add that if you wanted to. Broadly speaking, we use instant apply on macOS and iOS. In fact, all Apple's platforms. We prefer to just save it and stash it away and then provide undo later on if you want to, as opposed to making them press save and taking extra actions. We prefer things to just change if possible. So I wouldn't do that. Anyway, deleting stuff. In the same way as inserting is just calling model context.insert, deleting is just calling model context.delete, telling it what to delete. If you've ever used SwiftUI's onDelete modifier before, you'll know it expects to call a method that accepts an index set, a whole bunch of positions of items to remove from an array. We can just loop over that and say delete these ones here, 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 and here, and then it'll take care of the rest. So in our content view, I'm going to say as a method down here called delete people at offsets index set. We'll then loop over all the offsets, offset in offsets, and then do let person is people at that offset and call model context dot delete the person. That's it. Go over all the indexes we're asked to remove, find the person at that index, delete them. And with that in place, we can now attach an onDelete modifier to our for each up here somewhere, this one. We can do onDelete, perform onDelete, perform delete people. Just that. And that is deleting done. So we now have creating, reading, updating, and deleting the full CRUD stack in not a great many lines of code, quite frankly. Tyler asks, how do you delete all if you had multiple? If you want to delete every person, you can do that. In your model context, you will see there is a delete model option here. You can say delete person.self like that, and that will delete all people ahead of time. That would obviously blank out all the data, so use that one carefully. John, Matt, please don't use web views. They weren't cool in 2008. They're still not cool today. They're in fact terrible. Okay. So now we have deleting done. At this step, you're probably thinking, well, SwiftData looks pretty easy, you know? We can just run some code and it kind of takes care of lots of things on our behalf. Hooray! And it connects really neatly to SwiftUI. It's very, very easy. Well, our next task is more challenging. We're going to let users filter our list of people based on a search string. This is tricky because in SwiftData, we cannot dynamically change the sort order for a query. You just can't do it. Instead, we're going to go and push it somewhere else. Hi, Michaela. That alone wouldn't be too hard, okay? Except for the fact that we literally cannot change the query in place. We can't even make a new query here in content view. We can't change it here because yes, the data might change over time, but the query itself, the object itself, is read-only. Why no action with path in the delete function? Because swipe delete happens only on the main list when the path will be empty, like that. So this is going to be tricky. This is the tricky part in this whole project here. We're going to rearrange our code just a little bit, okay? We're going to make our content view responsible for handling navigation stack. That means its title, it means nav destination, it means toolbar, and so forth. But we'll make a subview, a view inside content view responsible for handling that SwiftData query. This means content view can also handle searching and later on sorting as well. And then when we change the search text, it will recreate the subview, and in doing so, recreate the subview's SwiftData query. So let's do this step by step. First things first, we'll add some new state here in content view to store whatever text the user is currently searching for. I'm going to say @state private var search text is an empty string by default. Second, we're going to bind that to a SwiftUI search bar using the searchable modifier. This is simple enough. We just go down here to our list and say under the toolbar, searchable, using the text of $search text. That will show a search bar, handle search text coming in and out, and synchronize it into the property for us automatically. Now for the tricky part. We want to try and split our content view into two parts. So the query, the list, and delete people, that method, all go into a subview that can be recreated whenever our search text changes. So press Command N. Make a new SwiftUI view. Call people view. Folks, I'm going to say this one last time. Yes, the video will be available after the stream finishes, and yes, the code will be on GitHub. If you are watching along and someone in the future, when in the future, asks that same question, please reply for me. It'd be very, very helpful. Thank you so much. New view, people view here. Step one, we're going to move from content view this people property. The whole @query var people person array. Grab that, Command X, paste it into people view down here. That. You have to add a SwiftData import so query works correctly, like that. Next, I'm going to copy the model context from content view to people view. Don't move it. We want it in both places because content view calls add person, people view will call delete. Both require the model context. So keep model context in both places. So over in content view here, I'm going to say this context, select it all, and just paste it into there in both places. Step 3, want to move the whole delete people method from content view into people view. So over here, delete people, grab that thing, Command X from content view, and then Command V into people view. Next up, want to move the whole list code. So this whole list here, not the modifiers, just the list itself. Grab that, Command X that, move it into the body of people view. And now all that remains is to change our content view so we use a people view here. Like that. Boom. Now you can, if you want to, run the app again, but there is no point. It's identical. We've just moved our code around slightly. Code that was previously right here in content view has been pushed one level deeper into people view. However, this reorganization serves an important purpose. We can now make a custom initializer for people view that accepts a string to search for and use that to remake its query every time that search string changes. Now, filtering in SwiftData requires some very precise code. So for now, we're going to use just placeholder code just to get it started. I'm going to fill in the rest of the code shortly, but we'll just get it at least up and running first. So in people view. Stream buffering. Oh no. Make sure, if you hit a problem, folks, hit Command R to refresh your YouTube stream. That might clear it up. We'll see. I'm fairly sure it's okay for me, but obviously I'm the one streaming, so who knows? Anyway, we're going to add the custom initializer here. So I'll say init here, we expect to be given that search string, which will be a string equal to an empty string by default. Like that. So I expect to be told what to search for. And then inside that, again, we're going to come back to this in a minute to explain it in more detail. But for now, we're just going to say underscore people is a new query with a filter being hash predicate, person coming in, true. Like that. So we're giving this search string here a default value of an empty string, which means we haven't got to change the preview code. That'll still work fine. However, we do want to pass in the search string from content view. So as the user types into the search bar, it automatically changes people view. It recreates it every single time, and in doing so, remakes the query every single time. And so in content view, we'll say this people view here, we're going to pass it the search string of our local search text state. Like that. The code builds. Doesn't do very much, but it builds. Let's now look at what it's actually doing behind the scenes. Is it efficient? Yes, it is, David. This small piece of code does, let's hide this bar perhaps, does three things all at once. And behind the scenes, it leverages some of the most advanced Swift code I've ever seen. It's absolutely remarkable here. Filtering a Swift data query is done by applying a series of predicates. These are simple tests we can apply to individual objects in our data, individual people. And what's happening is Swift data is going to say, I'm going to hand you one person, just a single person from my data. And your job is to return true if that person should be in the final array, or false if they shouldn't be in the array. Mocks if the underscore is required. Now remember, behind the scenes, under the hood, Swift data stores all its information in a database called SQLite. This database has no idea about Swift code. It doesn't care a jot about Swift. And so Swift does something remarkable, quite magical. It's able to convert Swift code into structured query language, or SQL, which is a language used to talk to databases like SQLite. Now, it can't convert all Swift code, obviously, and in fact only supports a fairly small subset of Swift. However, once you get the hang of it, you'll find these predicates work really well. So, with that in mind, let's look at our code so far. This thing here, this hash predicate part here, this is another macro. It's enabled to rewrite our code. Like I said, this behind the scenes converts our code, hi Baz, our code to SQL to run on the database here. It doesn't do it directly though. If you right-click on predicate here and choose, hopefully, expand macro, there we go, expand macro, boom, you'll see what it's doing. It converts our Swift code, this one true, into a foundation predicate with a predicate expression inside containing the word true. So it's a series of predicates and expressions it gets converted to. And then when the code actually runs, these predicates and expressions, they get converted into SQL that actually runs at runtime. The best part is this whole process is completely transparent to us. For the most part, you haven't got to care about it. That's the first thing. It's a macro that converts our Swift code to SQL stuff at runtime. The second part here is we're receiving one person to check. Here's an object. Should it be in the array or not? And right now we're just saying true. That means our filter does nothing. We're saying, yes, this person matches my test, include them in the array. So every user matches the test. Now, obviously, we want something more interesting here. We want to say, actually, only show people who have a name matching the search string. Now, we could write that by saying, does the person have a name property that contains our search string? But that's not ideal. And it's not ideal because contains is case sensitive. So you think, okay, it doesn't handle case very well. I'm just going to lowercase the name and lowercase the search string. So you might do person.name.lowercased.contain search string.lowercased. Problem solved. Great. Error. Sorry, lowercase isn't supported in predicates. Again, like I said, only a limited subset of Swift works inside macros. Let's predicate macro here. This is a good example. We can't just use lowercase here. It's just not supported. Helpfully, Swift provides a better solution here. Rather than saying contains, we can say perform a localized standard contains, which is the same as contains except it ignores case by default, and it also ignores diacritics, which means it ignores things like acute accents and grave accents and macrons and similar. And so a better way is to write our predicate like this. Does a person's name localized standard contains that search string? That's a big improvement. And it almost works, but there's a problem. By default, our search string is empty. And right now we're saying we want to send everyone back who has an empty string in their name, which doesn't make sense, right? So the final version of this predicate is actually going to say, is the search string empty? If it is, this person matches. If it isn't, perform a localized standard contains. So we'll say, if the search string is empty, then true, otherwise the same code as before. And with that in place, that is our query working quite nicely. Hello, dogs. The query is now working nicely. Now the third thing this code does is, as someone asked earlier, we're using underscore people here, not just people. This lets us access the underlying query itself. Now if we just use people by itself, you'll see in my code completion, this thing is an array of person. You can't put a query into it. That's how property wrappers work in the first place. They kind of masquerade their contents as being the actual data array of person or integer whatever it happens to be, right? By using underscore, we're able to access the inside thing. If I write underscore people here, you'll see, oh, now we're changing the query that makes people. So by using underscore people rather than just people, we're saying change the query itself, not just changing the array that results from the query. And now, hopefully I can press Command R and have searching working well. Let's add another user here. I'm going to add, let's do Arnold Rimmer, email address ace@reddwarf.com, notes, a total git, and then go back. And I can bring up the search by sliding down a little bit. And then I'll type in here, let's do D, A, V. Great. And you saw when I typed D, Rimmer still matches because of the lowercase d. It is case insensitive. If I just do only Rimmer matches. Okay, questions galore, crikey. We've got here, can you change SwiftData to change from Oracle DB2? No, you cannot, Michael. In core data, there were a variety of older backends you could write to. For example, you could write to XML if you wanted to. That is not the case in SwiftData. That's all gone away now. It's always SQLite. How does it compare to fetching and filtering the array? It's much faster, David. So the data's all there on disk. It only loads the ones that match into RAM to be returned back to you, as opposed to loading them all into Swift and then filtering out from there. If you imagine it loads 100,000 objects into RAM and then Swift throws most away, it'd be quite inefficient. This way it can kind of stream them in more effectively, which is better. Anyway, this is working well. You can filter users, but we can do better. Because if user types part of someone's email address, for example, that should also be included in the filtering. So really what we want to say is, if the name matches, or if the email address matches, or if the details match the search, then return true. And in Swift, that means using the binary OR operator, which is pipe. And so here, I'll just copy and paste this a few times. That pipe, paste, pipe, paste. And I'll change this one to be person email address and person details, like so. So it's now going to match all three things here. It's a small but welcome improvement. Now, tip for you in SwiftData, these predicates are checked in order. So it does the first one, then second one, then third one. So it's generally best to arrange these in an efficient order. That might mean putting faster checks first, like comparing integers before comparing strings. It might mean putting checks at the front that are more likely to eliminate users. You know, the name seems the most common one to me, so I'll put that one first. Here, it depends on the app you're building. David says, should we debounce for searching? No need. It is lightning fast. I really wouldn't worry. You know, fun fact for you, core data has an equivalent to model context, an NS managed object context. And for years, even today, we've all been told, before you call save on your managed object context, always check has changes first. Don't call save if there are no changes, you're just wasting time. And at Dub this year, I'm like, is that the case with SwiftData? It seems to save things automatically all the time. Is that still okay? I said, yeah, don't worry about it. It's perfectly fine. We've got no idea why the docs say that. Cool. So all this time we've been saying, you know, always check these things. It really matters. And they're like, nah, don't worry about it. It's fine. We checked that internally anyway. Cool. Antonio asks, is there a limit on how heavy the database can be? You mean how just big it can be? No, crack on. I mean, I wouldn't store binary blobs in there, images, movies, and similar. I was showing you how that's done later on. But, you know, make it as big as you like, quite frankly. Thomas, why is details green? It's Xcode. I don't know. It does that quite a lot. It thinks some things are one thing, something a different thing. I don't know. It probably recognizes from somewhere else. What do you think it is? No, it's not the right thing. It's just being silly. Xcode. I don't know. So now we have filtering by free text. I'm going to pause for a minute to say an important message. Below the video stream, it's a Just Giving link where you can donate to support this stream. I am raising money for folks experiencing homelessness this winter, escaping domestic abuse this winter. Your support matters. It is cold outside. They need our help. If you can, please donate. Thank you very much. Now we have searching. The next step is going to be sorting. And it's actually a lot easier now because it builds on the same principle we have for filtering here. Because just like we can't change a predicate dynamically, we also can't change sort order dynamically. And that means we also have to inject a sort order into the initializer here to change it automatically. Now, sorting in SwiftData can be done in two different ways. The one we're going to use here is both easy and powerful. We're going to pass in an array of a new type called sort descriptor. This lists properties to sort on, as well as if it should be ascending, like A to Z, or reverse ascending, descending, which is Z to A. And so, over in our content view, I'm going to add a new property to store our default sort order. I'm going to say @state private var sort order is an array of, and I'll say there's one sort descriptor using person.name with a backslash in front of it like that. It's an array containing a single sort descriptor with a key path pointing to a person's name here. We're saying sort our array, sort our result automatically by the people's names. I've marked it with @state. This is going to change over time. It's exactly what we'll do next here. To change the sort order, we're going to make a picker that will be bound to that sort order property here. And inside there, we can add various text options containing all the sort options you want to have. Maybe it's by name, name reverse, email address, I don't know. It's down to you, you're sorting. But here's the important part. No matter how you do it, each option you have must contain a tag that changes this sort order to something else that's meaningful, a different array of sorting options. I'm going to add just two options here. Name A to Z and name Z to A. So alphabetical and reverse alphabetical here. And so in our toolbar, I'm going to make a menu called sort with the system image of, so I can get this right first time, of arrow.up.arrow.down, yeah. And then inside there is a picker saying sort with its selection bound to $sort order. Like I said, there are two options. We'll do text, name, A to Z, and text, name, Z to A. Like I said earlier, we've got to give these things tags so it knows which one's which, knows what to do with a value when it's selected, what to assign to sort order. Now for name A to Z, it's just this array right here, the same thing we have right now. So I'll say this name has a tag of the default sort descriptor option. That's fine. But for name Z to A, I'll do tag the same thing and then change it slightly, because it's sorting by a person's name, but I'm going to add order.reverse. Go in reverse alphabetical order here. So the picker and the menu. This is helpful. This really matters because by default, without a menu, the picker will show its full option in the toolbar. It looks a bit silly. Let's try it now. See what I mean? I'll press Command R. It won't work yet, but you'll see it. There's our menu, and pressing it activates a picker. I can choose name Z to A, for example, like that. If I had not used a menu, if I just commented out temporarily, had the picker directly inside the toolbar, you get a very annoying layout. You get name A to Z showing, and then Z to A, which just looks weird. It's not like obvious what that even means. And so wrapping that in a menu really helps. So now we have all the UI to control our sorting. We don't actually do any sorting yet. For that, we're going to change our people view initializer, this one here, so it accepts a sort descriptor array to apply to its query. And so we'll modify this. We'll say you now have the search string, fine, and a sort order, which is an array of sort descriptor that describes the person object. Now this thing, sort descriptor, as you can see, is generic. It uses Swift's generics system. This is not any sort descriptor. It's a sort descriptor describing a person object. It sorts on name or email address or details and nothing else. To actually apply that to our query, we're going to pass a second value down here into the query just after the predicate. So right here, we're going to say the sort should be sort order. Just pass that right on. Now, doing that is going to cause a problem up here. I need a default value. That's fine. Boom, like that. That works well. But it'll break our content view because we aren't passing in a sort order. So we want to actually use that thing somehow. And so we're going to pass in our sort order alongside the search string in our content view. Where is it? Here. Boom. We'll just say sort order is our sort order property. And that is sorting done. I'll press Command R, run the code back. So right now it's sorting A to Z, so Arnold before David. Let's do Z to A, David before Arnold. So it's working nicely. Why is it a list and not a value? I literally don't know what that means, Moxific, sorry. Is there some more context in that one, perhaps, before I try to answer it? While they are retyping their question, just below the video, folks, is a link to Just Giving. You can help contribute money to support folks experiencing homelessness. Today's my birthday, folks. If you want to give me a birthday gift, please donate on Just Giving to support folks experiencing homelessness. So at this point, we're like an hour and 10 minutes in. We've got a basic app running here, but now I want to take it a step further. I want to track where we first met various people, so we remember them more clearly. Oh, I met them at so-and-so place, wherever, like this. This means adding a second Swift data model to our system. We'll call it events, and then linking events back to people. Before I do that, some questions about the sort order parameter. You need to write in a whole sentences here, Moxific, otherwise I don't understand what you mean. If you're asking why we just pass in the whole value here, I don't. It's an array. You can have more than one sort order in there if you want to. So you might have sort order by name, then by age, or by first met, backed by age, whatever. I don't know. We just pass the whole array in, but you can go to town, add all the values you want to in there. Brian asks, how do I sort by last name? You have to sort the first name and last name, store them separately as different strings in the database, and then combine them. Please don't just use string interpolation because names are complex. Particularly in Asian languages, you often have last name, then first name. Please use Foundation's person name components for doing that. But yeah, store a string separately and then sort on those things. Can you save sort order so it's the default order? You probably could, but you'd have to use an enum, Tyler. I don't think sort descriptor works well with app storage or similar right now. And so you want to back that out to an enum you can control more easily. Hi Scott, how you doing? Is SubU rendered because of state role? Yes. So Nof's asking why is SubU re-rendering? Because when we change the string, it recreates the people view struct every time, and then that forces the query to be run again with the new values being passed in. Stuff or Manuel asks, why does edit person view preview not work? Like I said earlier, I have disabled previews temporarily. I'm going to come back to them later on and add previews in most, if not all places. I'm doing it in one lump rather than doing it in bits and pieces everywhere. Alex, thank you so much. Thank you for coming along and donating. I'll do previews all in one lump at the end, or near the end anyway. Marco, yes, I'll be doing cloud syncing towards the end. It's going to happen. Antonio, show a person module. There you go. Boom. So that's our person model. We're going to add to this a new model called event that will track individual events, whether it's conferences, meetups, work things, I don't know. A variety of events can happen around the world, okay? So press Command N, make a new Swift file, and call this thing event.swift. Again, you want a Swift data import. and we're going to define a new app model class called event. This will have a name string and location string where it took place, plus that initializer made for us by Xcode. And that's a good start. Name of the event, where it took place, fine. This time I want to add something extra. I want each event to store exactly who we met the first time there. This means giving the model an extra property to store all the people we first met there. And so I add an extra property here. Var people is an array of person. Jake, yeah, you do. Yeah, you have to define initializers explicitly. Although Xcode, just type in, enter, it'll do it all for you these days. It's much easier. So this contains the people we met at that event. We're also going to do the opposite. We'll make each person know the event we first met them. And so, over in our person model, I'll add a property here, var met at an optional event. Now I've made this thing optional because it won't have a value initially. You just have to select where they met this person. The default will be unknown, no idea where you met them. Please choose from a list of options. If you want to, and I recommend you do, you could extend the initializer to add that met@at value inside there. I can just delete it and make a new one, in, boom, like that. It's nil by default, which is great. So that change means our connection goes both ways. Each person knows where we first met them, and each event knows all the people we met there. Both work both times. We've got a question. Is it possible to separate the same model container for different Xcode build flavors? Yes, you could use if, hash if, with some compiler flag being set according to you want to, and then it creates different containers if you want to. It's fine. Peter, thank you for coming. So we've just added a new property here. At this point, SwiftData does three things that are really smart on our behalf. First, it sees these two model classes reference each other. And so it creates a relationship between the two, which means if we set the met@at property of a person, that person will automatically be added or removed from the appropriate people arrays in an event class somewhere. Gary, thank you so much. That's the first thing. It makes a relationship for us. Second, because of that relationship, what will happen is it'll automatically create all the database storage to handle event objects. We haven't got to change our model container for person thing. We're going to do for person and for event. It knows person and event are attached somehow. And so by just saying, give me storage for parent, will automatically give you storage for events as well. And best of all, it will do what's called a migration for us here. It will automatically upgrade its existing database storage to add an empty value for where we met every person who was there already. So even though we've just changed the way our class looks, what it stores, it will silently be upgraded to say, okay, now you can also remember where they were stored. These all happen automatically, which is quite beautiful. David asks, could we keep met@at as non-optional? I mean, you could do. You've got a bit of a problem. We're not going to do it here, but in the future, if a person must be attached to an event, then adding a person means going into an event first, then adding from there to say where you met them. So it's always a value for event. But then in the future, if you were to add deleting an event, would you also delete all the people? If so, you can do that, but it requires extra work. This is the simplified approach where with an optional, SwiftData will make the two sides of the relationship for us automatically. ThemeX Digital says, can you have a struct of something inside a class like a present with present being named a certain price? Yeah, of course you can have structs inside class if you want to. As long as they conform to codable, they can be stored in SwiftData. If it's an array, though, you're making a lot of work for yourself because they'll all be stored directly inside the underlying database record for your class. It can make very, very large rows in SQLite, which is not a good idea. You also lose the ability to fine-grained querying as well, so I wouldn't recommend it if possible. Anyway, focusing. Migration's been done for us. Adding and editing events is partly code seen already and partly new code. First, the easy part. Make a new SwiftUI view. That's Safari. A new SwiftUI view here called Edit Event View. This thing has to know what event it's editing. So I'll say up here, at bindable, var event is an event. And again, it's going to break our preview. And once more, I'm going to say to you, just comment out the preview. We're going to return to this. We will fix it. Previews will work, just not yet. Let's build the app first. And now we can fill in the body of our view up here. I'm going to say we have a form with a text field inside called name of event. And it's text bound to $event.name. And then a text field called location with its text bound to $event.location. Add a nav title of edit event and a nav bar title display mode of .inline. That's the old stuff. Now it's time for the new work. We need a way to connect someone to the event we first met them. And that means adding some extra code over in our edit person view. This has to know all the list of events that exist, show them all in a picker, and actually attach those straight to the user. And so inside here, I'm going to add a new import for SwiftData. I'll also inside here add a query to read out all the events. And here's where that array behavior of sorting becomes very, very useful. I'm going to say sort by event name first, then sort by event location second. So if there's a tie, it'll do name first, then by location. So I'll say at query, with sorting being an array. We'll do sort descriptor, event.name, and then sort descriptor, event.location. This whole thing reducing the events property, which will contain an array of event, like that. Oh, I need a comma. Boom. Now this sort order is not going to change dynamically. It's just made once, fixed forever, it's fine, it can be right here inside the property definition. Now when it comes to adding an event, we're going to call an add event method that handles making a new event, adding to the SwiftData model context, and then navigating to it for editing. The code for that's going to come bit by bit in a minute, but for now we can at least put in a little placeholder method stub, func add event. Now for the UI of all this, we're going to add a new section to the existing form using a picker to select from one of the existing events I've made, or have an unknown event option for the default value for new people. We'll also use a section to add a button saying add a new event, which just calls the add event method. So we can get to that screen easily while we're making new users. And so before notes, I'm going to say there's a section here called where did you meet them? This has a picker inside. I'll do met at with selection bound to $person.met@. Like I said, the default value will be simply unknown event. We haven't said where this person was met just yet. But if the events array is not empty, empty is false, place a divider and then loop over all the events, give me one event in, and show a text view of the event's name. Then, after the picker, we have a button called add a new event with the action of add event, like that. Tyler asks, is there a way to make notes text field show a minimum number of lines vertically? If you wanted to, does line limit not work? I'd expect line limit works. Yeah. How to make text field string optional? Don't. Is there a way to int text field optional to 100% to 0? Optional values don't work great with bindings. You don't want optional bindings if possible. Dave, thanks for coming. Take care. And so now our UI's more or less in place. Okay, we can now fill in the add event method to create a new event and insert the model context. So I'll say down here we have let event, the new event. Again, no name, no location by default, just empty on screen is good. Shows the placeholders, and then we'll do model context here. Oops, daisy context dot insert that event. Now, that's not going to work, I don't think. Yeah. I haven't actually made a model context yet. That's my mistake. So I'll say up here, let's add that model context. So at environment / dot model context. Oops, daisy. Var model context like that. That should work. Read that SwiftUI environment incorrectly. Okay. That now works correctly. But there's a problem. Okay. We've made the event. We've told SwiftData to insert it. Go ahead and install this thing. But how can we trigger navigation to the event so users can edit it? Now, even if our edit person view had access somewhere up here to the path property from content view, we still couldn't place our new event inside there. This thing is an event object. Our current path array is an array of person objects. So we can't just put events in there, it wouldn't work. Now SwiftUI's got a solution for this, and it's so easy to use. We're going to just modify one line of code. The solution is called navigation path, which is a way of storing multiple types of navigation destination in a single value. If you're feeling technical, this thing is a type erased wrapper around our navigation destination, which means it can hold people, events, integers, strings, whatever you want to, as long as it conforms to the hashable protocol, which all these objects from SwiftData do automatically. And so we'll change this little bit here. It's not an array of person anymore, it is a navigation path. That's it. We're going to change the way it's used down here because nav path already has an append method attached to it. And that solves one problem. We can now push to both person and event objects. Now for the second problem, how can we manipulate that navigation path from the edit person view? Now one easy option here is just to pass that navigation path into edit person view as a binding, so we can change it directly. This is a binding, not a bindable. We're referring to some external state being passed to us. And so over in our edit person view here, I'm going to say we have an binding for the navigation path. Navigation path, like that. Actually, we're after bindable, I think, like that. Boom. So give me the path to navigate to. And now we'll send that in from our content view over here. We send in the person and the navigation path of our path using $, passing in the binding to the path so we can be changed inside there freely. And with that being done, our edit person view now has access to the same path being used in content view. It can add things and remove things and have a nav stack update automatically. And so back in add event, down here, hello dogs, down here, we can say navigation path append our new event, like that. That works great. Hello, you are very hungry today. Dear me. Anyway, so we're saying again, make the new event, add SwiftData, and then navigate to it straight away. Now, we haven't currently told SwiftUI what to do when it's handed one of its objects. It knows how to handle being given a person. Oh, a person, I'm going to show it a person view. But now it's been given an event. What should it do? The answer is we want a new navigation destination modifiers that says when you're given an event, please load our edit event view. Now, you could put this wherever you want to. I prefer to handle this inside edit person view because this is where navigation happens. And so here I would say there's a navigation destination for event.self with the destination being event in edit event view event of event. And that's most of the code required. But before we see what's missing, please go ahead and run the app now. Just try it out because you'll see the problem hopefully fairly quickly. Let's see. I'm going to go ahead and choose our river here. And as soon as I land on this edit person view, you see a big red message down here. The selection nil is invalid, has not got an associated tag as undefined results. Okay, let's ignore that temporarily. I'm going to press add a new event. I'll type event in here. I met this person at Dimension Jump, which is a big Red Dwarf conference, at least it was for COVID, in Nottingham. And it'll be here in our list. I'm going to choose going to that conference and nothing happens. So we have this big red message here. And we have selection not actually working here. Both of these are linked to the same fundamental problem and both have the same fix. We're going to attach tags to our picker values to understand what the option refers to. And so, up here for our unknown event option, this is going to have a tag of optional event.none. And now we change the for each text to be tag of event. So this is a small but important piece of code. We're saying when you choose the event, the thing they chose was that event, nothing else. Make that the selection being bound to met@. And when I choose unknown event, make that selection met@, set to optional event.none. Now, under the hood, Swift optionals, this thing here, are implemented as an enum. Here it is. It's generic with some kind of wrapped value, which is fine. And they're neat. They're designed to wrap some kind of value inside. Could be an integer, string, who knows what. It's an event in this case here. And you can see when we have our optional event, that's a generic form of saying it's some kind of optional event, but happens to be nothing right now. Because we can't just write nil here. Nil has no meaning by itself. Nil what? What kind of nil? Is it a nil person? Is it a nil string? A nil integer? Who knows what? And so what we're saying with this first tag is I am able to wrap some kind of event, but right now it's empty. It's nil. And in our current for each down here, we're providing the events themselves. We'll say, okay, here's the one to load. Here's the one to actually show with a selection. And what will happen is when you run the code again, it will silence the error message. It'll go away now. I can go to the view and boom, no more big picker errors. But when I change unknown event to be dimension jump, it still doesn't work. This is where it's a very subtle distinction. It really catches some folks out. This is an optional that happens to contain nothing at all, this tag here. This event right now is saying, I want to store the actual event for this selection, whatever's there right now. It's not enough because this is an optional event. This is a non-optional event. And this thing, met@, expects to be storing an optional event. Now we know this event exists. That's why it's in the array. Please show me this thing right now. It definitely exists. But SwiftData wants to be stored as an optional. And so we've got to say this event right now, the tag for it is optional event. An optional of the event that definitely always has a value, but it's still optional. And now, when I press Command R, the code will work correctly. I'll go in here, I'll choose this thing and choose dimension jump, updates correctly. So it's now working with our relationship smoothly. It's a subtle distinction, but it does matter very, very much. Okay, let's try and answer some questions. Did you ever struggle from PWM on high-end Macs? That's appalling. Cool. Do I mind going to event.swift? Of course, go ahead. There you go. That's the code there. What if MetaApp was an array of events? They'd have a many-to-many array. It can do that too. You'd want something more advanced. Maybe have like a multi-option picker, which you can't do in SwiftUI currently. You want to have a custom view, basically selecting various boxes. You could do it, but it'll be more work. Yoav, can you have multi-level relationships? I couldn't make it work with my app. I had a parent and a child. You absolutely can. It works fine. I'm not sure where you went wrong. So you can have as many levels as you want to. So A can have many Bs, B can have many Cs, C can have many Ds, and so forth all the way down. Just be careful, because you need to decide what's called a delete rule. When you delete your A, delete all the Bs as well, and all the Cs and Ds. You got to try and decide what gets deleted alongside it. Otherwise, you can leave data floating around, which isn't ideal, really. Okay, so now we've just added relationships. We now have two lots of data, people and events running here. We're going to do previews next. Beforehand, a reminder, below the video link is a just giving URL. This whole stream on my birthday is designed to raise money for folks experiencing homelessness. Please, if you can, donate some money at the link below the video. Aiden asks, does SwiftData relationship support relationships of the same type? Yes, you can do that absolutely fine. That's one of the best bits about classes, of course. They can reference each other very nicely. So managers can have managers, can have managers, can have managers all the way up if you want to. That's absolutely fine. Anthony, can we talk more about delete cascade and how to structure it better? I'm not going to do it here. We don't need @relationship at all here, because we have an array on one side and an optional value on the other side. SwiftData can infer the relationship for us and is doing so correctly automatically. It's very, very nice. If you want to change the delete rule, then you'd have a relationship macro attached to it. I have a whole free online book called SwiftData by Example that goes into detail on relationships there. By all means, check that out. Okay, next up. I've been ignoring previews intentionally, and there's still more work I want to do in this application. Okay, there's more I want to do, but at this point I want to pause for a moment to resolve this outstanding issue. How do we get Xcode's previews to work well here? This is one of the darker areas of SwiftData, we'll call it, okay? Because it does a lot of work behind the scenes and does so silently. Okay, if I were in edit person view and I want to bring this thing to life again, let's uncomment our preview. Okay, it's not going to work. It's saying you got to pass a person in. Your very first attempt might be to say, I'm going to make a person. I'm going to say make a person here, which is a new person with a name. Actually, fill in for me. The name of Dave Lister. Email address dave@reddwarf.com, details, empty string, and then simply return edit person view with that person being passed in, and the navigation path of, let's just do a constant navigation path, it's fine, boom, with the model container for person being passed in too. That is the, I'm going to call it naive in a nice way. That's a naive way of doing it. And what you get is that. You get a big problem report. You get a crash. It is crashing the whole simulator at this point. It doesn't know what it's doing. It's very, very annoyed. You cannot do that. And if you try and diagnose it, it'll tell you why. It failed to find a currently active container for person. Now, this is obviously a problem because you think this is correct. It's not correct because SwiftData is being sneaky. As soon as you call this person initializer here, as soon as you do that, it will silently look for, come on then, come on, let them see you at least, you get a treat. As soon as you call that person initializer, it will quietly and automatically look for whatever is the currently active model container, okay? And it does that to make sure everything's configured correctly. In our preview code, we are making the model container after we make the person object, okay? So there is no model container, hence that error. We can't find an active container right now and you're trying to make a person. That's not allowed. It'll just go bang and crash hard. And fixing this means making the model container before we make our sample data. But while we're there, we also have to enable another configuration option. We don't have to, we're going to, which is helpful, which says to SwiftData, this is previewing data only, just store it in memory. Store it in RAM, like a cache. Don't write it to actual disk. And so, if you make changes to our previews, they aren't being written to disk anywhere. They're just going to some virtual place in RAM, and when the preview refreshes, it gets thrown away straight away. Now, solving this takes quite a few lines of code. But because we're going to need it in more than one place, we're going to carefully isolate it out of the way in a new struct called a previewer. This will have the job of setting up a default container and adding some previewable data so we can use that shared code whenever we want to have previewing done in our SwiftUI views. And so I'm going to press Command-N, make another new Swift file here. Choose previewer.swift for the name. Give an import for SwiftData, and then give it all the following code. There's quite a bit. First things first, we'll say we've got a struct called previewer. Now this thing's going to work with SwiftData on its main context to insert data there into the main context. And again, that main context made for us by SwiftData only runs on the main actor. So we're going to tell Swift, this whole struct also runs on the main actor. So we can talk to that main context easily. We'll make this thing have three properties. We'll say there's a container, which is a model container. There's an event, and a person. We'll make three sample values for us to work with in our data. So we can have them all here for reading elsewhere in our application. We'll then make an initializer that can throw errors. We'll make a custom configuration, which is a type called model configuration. And this is where we can select is stored in memory only. Do not actually write this data to disk. I'll say true for that. It's just temporary data for previewing purposes only. We can then assign to our container try model container for person.self with that configuration. That makes the container, and it also makes the main context all in memory only. And now we can make our event and make our person and add them to SwiftData, and it'll take care of the rest for us. So we'll say our event is a new event named dimension jump, location Nottingham. And our person is a new person named Dave Lister, email address dave@reddwarf.com, details empty string. I'll add met at of our event, and to end up, we're going to add that person to SwiftData. So I'll say container, main context, insert the person. Now you can see I'm adding Dave Lister to SwiftData. I am not adding dimension jump to it. That is already linked from the person. It'll add both for us automatically. We add the person, it'll also add the event for us. So again, the key points in this particular previewer struct here, it has to run on the main actor. Without that, we cannot read this main context property easily. It's complicated. Second, we're saying store data in memory only. As soon as the preview is reset, clear the whole thing out from scratch, be much happier. Don't have to keep on deleting things automatically. Just do it for us. Just wipe it for free. Making a model container is a throwing operation. That's how I've made the whole thing throws. So the person using previewer has to handle that somehow. We make two pieces of sample data for us to work with, and then insert one of them. And again, that relationship means both will be inserted. And then we're storing the container, the event, and the person as properties here, so we can read them externally. I've made them all constant properties. It makes no sense to change them once they've been created. They're just for previewing purposes. And with that in place, we can now do previewing much more easily. So, back in our edit person view, here, I'm going to say, let's get rid of all this code for now. Let's say there's a do block. We'll make our previewer by doing try making a previewer, and send back our edit person view with the person being the previewer person and the nav path being the same thing before, constant navigation path, like that. Passing in the model container of our previewers container. There's a slight difference in that model container modifier. It's not model container 4 anymore, it's just model container with some container. We'll then do a little catch block and send back otherwise text failed to create preview with error.localized description being passed in. David asks, if we change the event of the person, will it automatically update the person's array of the old event and remove this person from it? Yes, it will. It's an automatic inferred relationship. It's very, very nice indeed. So that is one preview working correctly. Now I can press Option Command P and hopefully see, boom. Previewing now works very, very smoothly. We can do the same thing, almost more or less. I'll just copy the code in fact, and put that into Edit Event View. So over here, replace the current code with that thing. Obviously now it's an Edit Event View, not Edit Person View, and we'll pass in, there's no path anymore, it's an event really. Event is previewer.event, like that. Otherwise, failed to create preview. As you can see, boom, preview works great now. If you want to have good previews everywhere, of course it works great there too. So you go back to say content view, for example. It's got a very dull preview right now. Let's say instead make a new do block, make a previewer inside there, like that, and send back a new content view with the model container of our previewer container. And again, catch with, copy and paste that bit, boom, that. And so now we'll see an actual preview of data inside there. You can see example data is in there in the list very nicely. It's basically the same thing for our people view. So I'll copy that, go into people view, paste it on in here, make a people view instead, like that, boom. So at this point, hopefully now all your previews should show some meaningful example data correctly. Dominic asks, hi, I was trying to make a WatchOS app working on the same SwiftData cloud containers on iOS apps. I was following the guides your site has some error in the bundle ID. No, it's nothing special at all. It should work out of the box. I haven't done WatchOS for this project, but I did do macOS and iPad and iOS together, and all three synced beautifully. Okay, so now we have previewing working correctly. I'll say it again before we go to the next section here. Below the video is a Just Giving link. Today is my birthday. I am running a stream now, an hour and 3/4 in, specifically so we can raise money for folks experiencing homelessness or escaping domestic abuse. If you can, please contribute to the fundraiser below. Look for the Just Giving link below the video and give what you can, because it is freezing outside. It's a horrible, horrible time to be out in the streets. Okay, at this point, we have, I think, a pretty good app in place, okay? But there's another major feature I want to add. I want users to be able to import photos of people they've met, so they're easier to remember. That's why it's called, face facts, right? And so SwiftData actually handles this whole thing rather elegantly, I think. Rather than storing big image blobs of binary data inside our database, we instead suggest to it to store these things as separate files. And just reference the file name in the database. So it's much, much faster. Now, we don't have to do any of that naming, any of that referencing for us. It's just done for us automatically by SwiftData. Instead, we just say, hey, SwiftData, I think this particular property would work best as external storage. This is done with yet another macro. It loves macros. This one's called attribute, and it's attached directly to the property you want to customize. So, in order to write images out to disk from our person here, we're going to store them as optional data instances. There could be a picture, there might not be a picture. So I'll say var photo is an optional data. Like I said, we're going to use an attribute macro here to mark this thing as working best when stored externally. So we'll say attribute.external storage var photo is an optional data. So you can see we're now telling SwiftData explicitly this thing would work best as external storage. This is a suggestion. Internally, SwiftData can do whatever it thinks works best. But honestly, it doesn't matter to us. We've said it's a good idea. If it honors it, if it doesn't honor it, it's not our problem. We don't really care. The whole storage system is effectively opaque to us. We just don't care. So now we have somewhere to store a person's photo. We can build some UI around this to select that photo inside our edit user view. If you ever used SwiftUI's Photos Picker view, you'll know exactly how this is done. But I'm gonna walk through it here anyway. We're gonna say, first things first, let's add a new import in Edit Person view for Photos UI to bring in that extra frame what we need here. We'll then add a new property here that will store the user's selection. This is a special type called a Photos Picker item. When you select the picture, it's not brought in straight away. We get basically a URL to the picture, not quite, but basically. Here's where the picture exists in the photo library. When we actually want to load that, that's when the data is copied across from Photos into our app. But this first thing, the Photos Picker item, is like just a reference to where the file actually is. And so we'll say in here, @state private var selected item is a Photos Picker item optional. There isn't one by default. And now we have that, we can bind this state here to a Photos Picker view, which will take care of showing all the photo selection UI for us automatically. What we're going to do is place a section somewhere in here with the UI. I'll put this before the name, I think it works best. I'm going to say the section here with a Photos Picker inside. The selection is bound to $selected item. I'm going to do matching images. We don't want to have like cinematic videos, for example. That'd be weird, or screen recordings. I'll just do images. And the label is going to be a label saying select the photo and system image of person, like that. David, I can't quite read your question because YouTube puts a little heart mark in its way. Will it replace this or if we replace it in UI? In UI? I'm not sure what you mean, sorry. If you choose a new image, it will overwrite the old one, if that's what you're asking. It won't keep multiple images around as you ask it to. It'll keep only one around. So that lets us select a picture here. When it comes to handling selection, again, that Photos Picker item value isn't the actual image data, it's just a reference to it. Oh yeah, it's over there somewhere. We've got to call load transferable type on that object to get the actual data of the object through. This matters because imagine like a panorama. They're very, very, very big pictures, right? They're huge amounts of data. And so it's not instantly copied across to you. It's done asynchronously when you're ready. And so we can have a separate method here in our edit person view that will call that load transferable type method and assign it to our person's photo. And it will do this on a separate task asynchronously. So it can go to sleep for a while work's being transferred, while data's being transferred, and assign it only when it's finished. So down here, I'm going to add a method called load photo. Let's make a new task so it can work asynchronously in the background. We're going to say here, our person's photo is try await the item they selected .load transferable of type data.self. Now that alone isn't quite enough. This code is likely to go to sleep for a while it's being copied across from the photo library. But when it's finally loaded and it's being assigned to the person's photo, that part will update our UI to show the picture. And so it's really important we put this whole task on the main actor, like that. Make this task run on the main actor so we change the photo from the main actor. Keep that thing safe. Jacob asks, do I have any thoughts on the composable architecture? Easy question, no I don't. This method, load photo, has to be called whenever our selected item changes. So I can choose a picture or change their mind again and again and again. How much do you want to here? And so below the nav destination, I'm going to add an onChange modifier that tracks onChange of selected item. When that changes, just call load photo, like that. So we have somewhere to store the picture. We had a picker bound to that somewhere. We've got a method to load the photo into our person's photo, and we have an onChange to hook it all together. At this point, all the code's in place required to select and load a photo. We can now try to put it on the screen somewhere. Now this contains raw data intentionally, so we can read and write from disk smoothly. SwiftUI's image view has no native way of being loaded from image data. So we're going to bounce this thing through a UI image first, or an NS image if you're targeting macOS. And so, in our very first section up here, before the photos picker, I'm going to say if let image data equals person.photo. Do we have data here? Oops, photo with a P. Like that. If that is true, do we also have the ability to make a UI image from that? Is this a valid image inside here and not like a zip file or something? We'll do let UI image equals UI image data of that image data. If both those are true, we now have a valid UI image containing the person's picture. We can place that inside a SwiftUI image. I can say image, UI image of that UI image. I'll make it resizable and scaled to fit. And that's it done. That's all the code done. We can now import a photo for a user and have it automatically saved in an external file by SwiftData here. We've had to make no special accommodations for this thing being external storage. It's just taken care of for us automatically. Now, if you press Command R and run your code again, we should see it working. I'll go to here, choose select photo. There's these 6 pictures. It's rather dull. I have some pictures pre-prepared. If I go to the Photos app over here, there's the default sort of Iceland pictures, whatever. In my Finder, I'm going to People. Here we go. These are my red dwarf people. We have Lister, we have Rimmer, and we have the cat. I'm going to drag those 3 into images, like that, so we can hopefully import them, or at least import one of them. Oh, there we are. All 3 arrived eventually. Took a second to get there. So now we have some meaningful pictures to work with, not just pictures of Iceland, even though Iceland's very nice. And then back in our app over here, I'm going to try again. Select a photo. There we go. I'm going to select Rimmer. There we go. You can see it all slides in correctly, and it's all being stored back and forward. It's being saved correctly to the file. It's all working very, very nicely. ThemeX Digital asks, would it be much more work to open the camera to get a picture? Yes, it would. Vast amounts more work, because annoyingly, SwiftData has a brilliant built-in way for choosing, SwiftUI, sorry, brilliant built-in way for choosing pictures from the photo library. Has not got a way to select pictures from the camera directly. If you're using UIKit, you'd use UI Image Picker Controller, which can do both in one controller. SwiftUI only has half that functionality, which is frustrating. I have filed feedback asking for it. I suggest you do the same thing. If you want to do it, you can do. Just wrap UI Image Picker Controller in your own SwiftUI UI View Controller representable. Anyway, now we have external data. We have pictures being imported as another big check of our list done. Before we continue, below the video link is a Just Giving link. Today's my birthday. If you're enjoying the stream, if you're learning something along the way, please donate to that Just Giving link. I am raising money for folks who are experiencing homelessness or escaping domestic abuse. Right now, they need all our help. So if you can, please support them with a donation in the link below. So Stuff/Manuel saying, don't forget by saying please in your feedback. You're absolutely right. If I launch my feedback here, that's my password. There we go. You'll see my feedback for this. I think I filed it yesterday. Blah, blah, blah. Submitted. This one, maybe? Nope. This one. There we are. Boom. Please add support. You're nice. Thank you. They're working very, very hard, and there aren't very many of them. Occasionally, like extremely rarely, maybe 1 in 1,000 times, I get a bit snarky in my feedbacks. But mostly I'm like, please, please, thank you, thank you. I'm trying to be, remembering the human exists. Anyway. But Tyler asks, why are some photos put upside down? That is, so internally, to make, less data loss, basically, pictures are stored in a particular orientation, and then they have a metadata attached to them saying, now rotate to this orientation at runtime. And so when you rotate a picture, normally it's just staying as it was. The pixels aren't being moved at all to avoid, JPEG recompression again and again and again. It just changes the option saying now it's clockwise, now it's counterclockwise, whatever, degrees, like that, right? And I don't think SwiftUI takes that value into account right now, whereas UIKit does. It's not ideal. That's my guess. I don't actually know. Michael, no, you need no special image transformer here. Just make it data and go from there. And it's all external as well. It's very, very nice. Okay. We're not finished yet. There's still more to do. We're now 2 hours, and I'm going as fast as I can, folks. I'm really flying through it, but we're 2 hours in already. There's one more massive job, well, job at least, I want to do. I want to add iCloud synchronization. So we back up our data to iCloud. So a user with an iPad and an iPhone and a watch and a Mac, whatever, can all share the same data correctly. It's an important feature. And it's actually fairly straightforward because SwiftData takes care of almost all the work for us. But there is a catch. There's always a catch. iCloud has special data requirements that go above and beyond what SwiftData has. And we've got to follow those or our data will not sync to iCloud. To get started, you want to choose Face Facts at the very top here. Then choose the Face Facts Target option here. Then choose Signing and Capabilities. We're going to add the capability of storing data in iCloud. To do that, you press plus capability, search for cloud, and select iCloud. Like that. It'll have a little think. Now you need to check the box here saying CloudKit. I want to store my Swift data information in CloudKit. But you've also got to attach a container. Where in iCloud should it be stored? And you can see right now I have one already made out for Face Facts. That's my bundle ID, com.hackingwithswift.facefacts is my bundle ID, prefixed by iCloud. I'm going to check that now. Use that to store my data in iCloud. You won't have one of these yet. That's okay. Just press plus. Call it iCloud.yourbundleid.whatever. In there to make your own container for iCloud. Then check that. Either way, you must have CloudKit and have a container checked here. Once you have that, I want you to press plus capability again, because we're going to add a second capability here called background modes. So our app can do things in the background. So press plus capability now, choose background modes, and enable the one here called remote notifications. This means CloudKit, iCloud's platform, can notify our app in the background, oh, by the way, your data's changed. So SwiftData can start synchronizing data when the app isn't even visibly running. So it stays updated automatically. So you want to check CloudKit, add a container, and the remote notifications background mode. And that completes our configuration changes. And so now I want you to try running the app again. It's not going to work, but let's run it again. Brace yourself. iCloud and CloudKit, I don't know why, they just love just spewing logs into Xcode's logs. It just vomits up text galore. So brace yourself. Command R. Let's make this thing big so you can see all the logs going to spit out of me. Blah. Stuff. Yeah. Lots of logs. And that's not even more. It'll do more. It's actually working, okay? Now, the reason I'm saying this is because if you look at the top, you'll see a bunch of big yellow messages here. It's not happy with us. These are the extra rules that CloudKit has that SwiftData doesn't. It's saying you cannot use CloudKit. There's a massive error now occurring because our classes don't follow CloudKit's rules. Specifically, we must make sure that all our properties have a default value. And also that all relationships be marked as optional. Now, in this app, by no sheer coincidence, this is actually very easy to do. Because for our person class here, we can just say, fine, it's an empty string by default for all these things. That's already nil by default. It's an optional. And then for our event class, we can say the name, empty string. Location, empty string. This thing is a relationship that has to be optional. So I'll say you are an optional person array equal to an empty person array by default. And that completely solves iCloud's concerns. Now we have default values to all properties, and our single relationship, this one here, is optional. Moxific's asking, do you need a developer program for iCloud? I believe you do. I believe you do. With those changes, hopefully, all the iCloud errors will now go away. We're now able to store things in the cloud. It's all loading correctly now. There's no more big yellow messages, log errors and stuff. It's all happy. This thing here is angry about some URL thing. Yeah, that's just saying it hasn't got an iCloud account. We're in the simulator, okay? And on that note, by the way, and honestly, I've said this so many times, and no matter how many times I say it, people still don't listen to me. It's very frustrating. Using iCloud in the simulator is a very bad idea. Okay, you can do it. You can log in there if you want to, fine. But it will regularly misbehave or fail entirely. The only way you can actually test iCloud well is on a physical device. Get your iPhone, get your iPad, whatever it is, use physical devices signed to iCloud to test iCloud syncing. Because if it works in the simulator, it's basically luck. It so often completely fails. Do not use iCloud syncing in the simulator because it just won't work most of the time. Now, that's not to say that devices work all the time too, okay? Very often, the plague of developers' devices is the dreaded CloudKit error 500, Apple's way of saying syncing just failed completely, sorry. And there's no way to fix it other than going to the iCloud dashboard and pressing reset environment for your container. But that does indeed add full iCloud support to our app. So at this point, we've got sorting, we've got searching, we've got relationships, we've got the CloudKit, we've got previewing, we've got external storage and images being pulled in. This is a good rounded app. It's in a good place. I'm taking it no further on this stream. That was 2 hours and 10 minutes, not bad. If you've enjoyed the stream, if you've learned something along the way, please take a moment to click the link below to justgiving.com, make a donation. You'll see it in the stream link below. I'll try and bring it up again because it does matter. Where is it? One of these billion things. That's the one. Nope, that's edit your page. Bah, humbug. One of these pages here. That's it there. Boom. This thing here. We've smashed the target. Thank you so much for your generosity. It's really, really nice. It's very kind of you folks. There's still time to donate. This fundraiser is going to stay alive for at least a year or something. So if you watch this video like in a 6 months time, it's still good, still enjoyed it, please contribute something to help fight this problem we have, which are too many folks on the streets who need help, who aren't getting help. Too many folks escaping abuse domestically aren't getting help. Please help us fight that problem. If you have questions, of course, I'm happy to stay around, do my best to answer some. It is, as a reminder, my birthday. I'd like to go and have some birthday cake along the way and have a nice time with my kids in the evening. But I do this every year, so this is the 4th year now I've done the same thing, building an app from scratch with SwiftUI. And I know folks enjoy it very much. And we raise lots of great money for charity too, so it's a good thing. If you have questions, please just go for it. I'll do my best to answer them as we go. Ryan, can you talk about SwiftData's flexibility? Can you create your own indexes, write custom SQL queries? So, can you make indexes? No, you can't. You ought to be able to. You certainly can in core data. I think Apple said this would come in the initial beta. It didn't land in time, so it was yanked out before release. I'd like to think that'll land at some point. Hopefully by 18, iOS 18 that is. Ideally before. But yes, being able to say attribute indexed is on the cards as a thing they can add, I believe. That'd be very nice indeed. To say, yes, this thing, trust me, this thing should be indexed. Would be nice indeed. Can you run SQL queries? No, you can't. As far as it's concerned, there is no SQL here. It's all just SwiftData. And so, no. No, I did not have my cake yet. Sorry. Yeah, I'm going to try and find some sort of cake that the dogs can enjoy, you know, sort of tuna cake or something. You've got a crash and model container. That feels like you haven't got a model container in place when you're making a model object. I don't know. Obviously, that's your code to diagnose more accurately. David, can you query based on relationships? Yes, you can. It's actually fairly powerful. I did mention to you briefly that the hash predicate macro, which we used in PeopleView here, converts your code into a series of predicates. Let's have a look at that, how that looks. If I expand this larger one, you'll see it does some absolute magic here. Look at that. It's so much work. It's absolute genius Swift code happening here. Anyway, you can, and it's surprising the amount you can get away with. And annoyingly, if you ever use core data, it used what we call stringly typed predicates. Your predicates were strings, and they were obviously not safe. You have to run the code to see if it works or not. SwiftData does compile time checking your predicates, but occasionally, just occasionally, will still go wrong. Because it isn't perfect. It'll still crash at runtime if your predicate's bad. So please check that one carefully. Any more questions? Nick, more of a web dev here. Curious about iOS. It seems like it's just Apple's design. Oh yeah, you can go to town, Nick, with custom design if you want to. I'm not doing it here. The problem with custom design is, you know, by all means do it. I love good custom design. The problem is that most folks who do it don't stop and take the time to make sure that design works well for everyone. So for example, all of Apple's controls, the list, the nav bar, the tabs, the buttons, you name it, every single one have been polished and polished and polished again to handle things like dynamic type, where the font gets bigger or smaller according to user settings, to handle things like voiceover support, so users can swipe their way through and access the entire app, even if they're completely blind. And a lot of folks go for like, oh, it's gorgeous design, straight from like Dribble, whatever, and it's completely inaccessible to voiceover. Like, a blind person can no longer use the app. This happens very, very painfully often. Just this this year, Blue Sky, the fancy new social network, managed to launch several months with zero voiceover support. It was completely impossible to use with voiceover. They used React Native for, I'm not going to get into why it's good or bad, but it meant they weren't using Apple's native controls anymore. And so it was very, very hard to use for folks who couldn't see. And so, yes, you can go to town with gorgeous custom designs, but please take into account people who need extra support for things like color blindness or font size or whatever. Aiden, so you can customize it. Actually, the question from Aiden, can you customize a searchable placement? Yes, you can. When you're saying searchable, here, you can say placement, boom, right there, and customize how it looks. So I might say this thing, bind search text with placement of one of these. So the sidebar, the toolbar, you choose it. That is an option you can choose if you want to. David, can I do some more work? I mean, it's 2 hours and a quarter. I've got stacks of examples. Just Google up SwiftData by example. You'll find stacks of examples of relationships and queries in there. Please use that. I'm not doing any more at this point. Serious Cat, do I see any benefit to adding SwiftData apps that are already using Firebase or a similar Cloud DB? I get folks often asking, should I migrate my core data code to SwiftData? And I answer the same way I answered the same question when it came around years ago. Should I migrate my Objective-C code to Swift? No, you really shouldn't, because you have a great, hopefully, shipping app that works well. It's tested, it's bug-free or more or less. It works well. If you rewrite that in SwiftUI, or in this case, SwiftData, the best result you'll get is exactly the same thing you had before. The worst result will be all the same bugs you had before, plus a whole bunch new bugs in your translation layer. Copying things to and fro, whatever, can get quite messy. And so, broadly speaking, if you've got a great system already, whether that is, I don't know, Firebase or whatever, if it works for you, use it. I'm not some zealot who'll say you must use SwiftData. I hate those kind of pointless petty wars. Use what works well for you. For me, that's SwiftData. If that's Firebase for you, you do you. You rock on. I love it. Internet high five. Anthony, yes, accessibility is important. I can't say it. It's one of the few words I can't say in a sentence. Accessibility. But it is critically important, and I will always fight for it. Any more questions before I go? And leave you all free to rewind and figure out what I was saying halfway through. Does SwiftData provide thread safety? Yes. Use it carefully, and I do explain this more in the book SwiftData by Example, which is free online, by the way. SwiftData by Example, it's all free online. It's built with Swift concurrency in mind, which means things like model instances, like an instance of a person or a model context, cannot be passed around from task to task. They are not thread safe. They're not sendable. Okay. A model container, the underlying database storage, is sendable. It is safe to be passed around to another actor, for example. And so, if you wanted a background actor doing some work in its own model context over here somewhere, you would pass in the model container and make a local model context on the other actor. And that would be safe. Don't try and pass in the context. That won't work very well. Everyone go and buy a book for Christmas. Yes, please. Buy a book for Christmas. That's a great gift to yourself. Will I make a video, says Just Smile, for folks who struggle to choose between web or iOS? No, I won't. Choose whatever you want to make and have fun with it. I love building web stuff. I love building iOS stuff. I love just building stuff. Go and do whatever makes you very, very happy, and I will be right behind you. Ditmas, are you interested in working in a time machine? Sure. Yeah, come and meet me yesterday and with your time machine, and I'll discuss it with you. If you can't do that, it doesn't exist. JogQ, if you embed an MTK view in SwiftUI, the SwiftUI views will I don't know. I don't have access to SwiftUI source code, folks. I have no idea what it's doing behind the scenes. You go ahead and talk to Apple directly. File a DTS report. DTS is great for that. Talk to Greg and the DTS team. He does metal, and he can help you out. He's very nice. Nick says, Paul, with custom views, can you completely roll your in-custom interface? No, you can do whatever you like. Nick, you can go to absolute town and draw whatever you want in any way you like. It is extraordinarily flexible. There are some gorgeous SwiftUI interfaces out there built completely from scratch. Their own shapes, own designs, own buttons, or whatever. It's down to you. Just please, please, if you remember nothing else, make it accessible to people who can't otherwise use the app. Like switch control, for example. Anthony just learned about SwiftData by example. Folks, it's really, really good. You want to go to hackingwithswift.com, quick start SwiftData. It's free, it's massive, it contains lots and lots of questions about SwiftData, all answered really, really quickly and easily. So please do check that out. Eric, you're most welcome. Tuareg, what were the reasons between images behaving better in a horizontal H stack rather than a lazy H stack? A bit of an off-topic question there, Tuareg94. A lazy stack has no idea how big its contents are going to be. Are they all going to be small, all going to be big? We don't know, okay? And so it automatically stretches to fill the screen. It fills all the available space to play it safe. Otherwise, it might start small for a small image, and a bigger one scrolls, and it kind of grows to be bigger. Whatever, it'd be very annoying, right? And so it stretches to fill the space. A regular H stack doesn't do that. And so that's the difference. Maybe it's causing that. I'm not sure otherwise. Miguel, what's my opinion on the singleton pattern now we have observable macro working so well and performant? The app model is what you're calling it really, a single app model rather than a view model that controls a whole app is now obviously feasible. It was a massive performance trap before, because changing one view would change every view. It'd be a bad idea. It's not really a singleton. It's just a single instance of an object that happens to be made just once, but it could be made more than once. It's fine. Go for it. I think that's a great solution these days, thanks to observable. Singletons themselves, forcing singletons, can cause testing problems. So I'll be reticent to go down singleton unless it was the right solution. So be careful. Just smile. The market's hard. It is hard. Everyone's hard. We are in a recession still worldwide, and so it's difficult. Marco, yes, there'll be a GitHub repo tomorrow, probably, when I've had my cake. Okay, that is now 7:20 UK time. If you have last-minute questions, now is your chance. Please do ask them. Otherwise, I'm going to skedaddle and watch probably Home Alone, because it's almost Christmas time with my kids. Last chance. Any more questions? Occasionally, staff, you press Command R, it refreshes the stream and fixes the problem. It's kind of hit and miss sometimes. Streaming, it's hard. Who knew? Okay, that's it from me, folks. Again, below the video, Just Giving link. Please donate what you can. It's a really important local charity who do some fantastic, fantastic work. If you enjoyed the video, if you learned something along the way, please donate. It makes a big, big difference. Even just a few bucks or pounds or euros, whatever, it really, really helps. Every little bit helps at this point because it's very, very cold and these folks need our support. If you have further questions, you can try asking them, but I'm going to be somewhere else, so you might want to use Twitter. Otherwise, I won't see them. The source code will be online on GitHub at some point in the future, hopefully tomorrow. And the video will stay here on YouTube for rewatching as much as you want to. And of course, you can add comments below. Please do leave a like or subscribe, all that kind of, YouTube jazz. It all helps the algorithm slightly. And I am unlikely to see you again, folks, between now and Christmas, so I hope you have a wonderful, wonderful break. If you don't celebrate, at least have time off, watch TV, play video games. If you do celebrate, I hope you have a lovely, lovely time with your family and get all the gifts you want. Take care, folks. It's been a pleasure having you all. Take care.